Hello, scholars and cyborgs. Welcome back to Math with Marcus. This question comes from Course 1. It's the Chapter 5, Locating Fractions on a Number Line. This is a great problem. So it's asking us to copy the number line below on your paper, including the dots here, and then keep the dots in the same positions. Label each dot with one of the fractions from the list given below. So it wants us to label each of these with what fraction each of those dots is. This problem is incredibly overwhelming if you don't take it step by step. And if you notice that these points are grouped, so some are grouped really close to 0, some are by 1/2, some are close to 1, and some are around 1.5 and 2. So they kind of go through here, and it says, when making estimates, sometimes useful to approximate unfamiliar fractions by comparing them to numbers that are more familiar. So it's saying, hey, which of these are close to 1? And then we're going to order those. Instead of trying to get a common denominator between all these fractions, which would be ridiculously hard to do. So what we're going to do is we're going to take this. We've got our number line drawn. I even broke it out with colors. So which of these fractions are greater than or equal to 1.5? So I'm looking for numbers that are bigger than 1, but kind of a lot bigger than 1, 1.5 or more. So no, that's a little bit bigger than 1. Hey, this is more than 1.5. That's almost, it's pretty close to 2. That's 1.5 there. A little bit more than 1, but less than 2. No, less than 1, less than 1. Here we go. This looks like another number that's pretty close to 2 whole. No. How many are we looking for? We're looking for 1, 2, 3, 4 numbers here. So 2.5. Here's one that is 2. And then this one's almost a full 2. And so those are the numbers that we're ordering here. Now, of those, I know which one is 2. So I can put that right here. I know that this one here is 4/2. 4 divided by 2 is 2. I know that this one here, and then let's look for which one is out of these 3, is there one that is the next closest, let's look for the one that's furthest away. That's one that's not really as close to 2. So, out of these, 15 out of 9. So if it was 18 out of 9, that would be 2 wholes. This is 30 out of 16. So if this was 32 out of 16, that would be 1. That would be 2. And then here is 20 out of 11. And if this was 22, that would be 1 whole. So this is 2 parts away from being 1 whole. This is also 2 parts away from being 1 whole. I'll just write that down below. 32/16 is 2 wholes. And then here, 22/11 is equal to 2 wholes. Here, this would be 18/9 is 2. And if we look, these both are 2 parts away from being 2 wholes. And so I'm looking for which one of those are smaller pieces. So 16ths are smaller than 11ths. So this is missing less than 2. So this is larger. 30 out of 16 is the larger one out of this. So 30 out of 16 goes here. And then this one is going to be 20/11. This is 3 parts away, and these pieces are larger than the rest. So it's missing 3 parts. So from 15/9, 18/9 would be 2 wholes. So it's missing 3 pieces from being 2 whole. And 9ths are bigger than 16ths and 11ths. So it's missing 1 more part from being a whole, and it's the pieces are larger. So this is 15/9. Okay. Now, which of these fractions are closer to the number 1? Okay, so we're looking for 1, 2, 3, 4, 5 that are close to 1. So I'm going to look for the ones that are close to 1. I'm looking for 2 that are a little bit less and 3 that are a little bit more. So 7/6 is a little bit more. 13/12 is a little bit more. 6/7, a little less. 98/100, a little bit less. 6/5, a little bit more. So 1, 2, 3, 4, 5. There's our 5. So out of the 2 that are less than 1, we've got this one here. and this one here. So which one of these is closer to one whole? Well, that's this one. It's 2 pieces away from being a whole, and this is only 1 piece. But this 1 piece of pizza is a lot bigger slice than these 2 pieces. 100ths are very small compared to 7ths. So we've got 98 100ths here, and then this one is going to be 6/7. All right, and then we've got we're looking for one that is just a little bit bigger. Well, I guess just which one is bigger than 1. So all of these are 1 piece more than 1 whole. So 7, 6, 13, 12, 6/5. So if each of these are 1 bigger, which of these has the smallest slices? Which one is bigger by which one is bigger by the smaller piece, I guess? And 12ths are smaller than 6ths, and 6ths are smaller than 5ths. So this would be 13. This would be 13 12ths. This would be 7 6ths. And this would be 6/5. All right, now we're looking for the ones that are by a half. So which ones of these are close to a half? Those are pretty small, pretty small. This is close to a half, and this is close to a half. All right. So one of these is a little bit more than 1/2, and one of these is a little bit less. So take a minute. Which one of these is a little bit less than 1/2? Which one's a little bit more? If you said that 12 out of 25 is a little bit less than a half, you are correct. So 12 out of 24 is 1/2. So 12 out of 25 is a little bit less. And 6 out of 11 is a bit more. So 6 pieces out of 12 is a half, and this is 6 out of 11, so that's more than half. All right, the last one is these, and these are all pretty closely grouped together, so this is probably going to be more tricky. So 1/12, 6 100ths, 2 17ths, 2 20ths. So we're going to need to organize those from least to greatest. So I'm going to write those down below, give us a little bit more room. Let's pause it for a minute. All right, so now that we got our fractions here, I see that 1/12, 6 100ths, 2 17ths, and 2 20ths. One method to compare fractions, which is fantastic, is to get all the denominators to be the same number. Another way that's less commonly used, but you can also get the numerators to be the same, and say, what if they all had the same number of pieces, and then compare the size of the pieces. So let's go ahead and do that. So if I notice I can get all of these numerators to 6 pretty easily. So if I multiply this by 6 sixths, this is already in sixths. Multiply this by 3/3, and multiply this by 3/3 as well. And then that's going to get us 6 on the top. And this is going to be 6 out of 100. This is going to be 6 pieces out of 60. This is going to be 6 out of, what would that be, 51? 6 out of 51, and this is 6 out of 72. And now we just organize them. So I would rather have more pieces with less, the pizza cut into less slices. So I'm going to put it from smallest to biggest. So 6 out of 100 is the smallest, followed by 6 out of 72, and then 6 out of 60, and then 6 out of 51. So least to greatest. So this 6 100ths is here. So 6 out of 100 is there. This one here is 6 out of 72, which is 1/12. This one here is 6 60ths, which is the 2 20ths one, 2 out of 20. And the last one here is the 6 51, which is 2 17ths. All right. Many ways to do this problem. It's a good one. It's great for the brain. If this video made sense, pause it, turn it off, try it again. It's really great practice, and I can't stress enough how important it is to work with number lines at a regular basis. So thanks for tuning in. Catch you around.